In this video, we are going to look at this problem on page 10 of the Chapter 3, Section 2 slides. So here is our example. Curtis Rowe Aviation Industries has two plants, 1 and 2, that produce Zephyr jet engines used in their light commercial airplanes. There are 100 units of the engines in Plant 1 and 110 units in Plant 2. The engines are shipped to two of Curtis Rowe's main assembly plants, A and B. The shipping cost in dollars per engine from plants 1 and 2 to the main assembly plants A and B are as follows. To ship from plant 1 to assembly plant A is $100. To ship from plant 1 to assembly plant B is $60. To ship from plant 2 to assembly plant A is $120. And from plant 2 to assembly plant B is $70. In a certain month, assembly plant A needs 80 engines, whereas assembly plant B needs 70 engines. Set up the problem of finding how many engines should be shipped from each plant to each main assembly plant if shipping costs are to be kept to a minimum. I've already stated some information that we need from this. We've got X is the number of engines from plant 1 to assembly plant A. Y is the number of engines from plant 1 to assembly plant B. And then because plant A needs 80 engines, the number of engines from plant 2 to assembly plant A will be 80 minus X. And the number from plant 2 to assembly plant B will be 70 minus Y. So these numbers can be displayed in a schematic like this. Here's plant 1 and plant 2. Here's, let's call this A, assembly plant A, and over here we've got assembly plant B. And we know that this is X, this is 80 minus X, this is Y, and this is 70 minus Y. So we can move on from here. With the aid of that schematic, we are able to, and the shipping cost schedule, we find that the total shipping cost incurred by Curtis Rowe is given by C equals 100X plus 60Y plus 120 times 80 minus X plus 70 times 70 minus Y. And simplifying that, we get 14,500 minus 20X minus 10Y. The production constraints on plants 1 and 2 lead to the inequalities. X plus Y is less than or equal to 100. And 80 minus X plus 70 minus Y is less than or equal to 110. And that last inequality simplifies to, that's an equivalence symbol. If you haven't seen one before, that's X plus Y is greater than or equal to 40. Also, we know that X is greater than or equal to 0. Y is greater than or equal to 0. 80 minus X is greater than or equal to 0. And 70 minus Y is greater than or equal to 0, which means that X is less than or equal to 80 and Y is less than or equal to 70, which are equivalent to these statements here. So we've got some constraints on this problem. To summarize this, we have the following linear programming problem. Minimize the objective cost cost function C equals 14,500 minus 20x minus 10y, subject to the constraints x plus y is greater than or equal to 40. X plus y is less than or equal to 100. X is less than or equal to 80. Y is less than or equal to 70, where X is greater than or equal to 0 and Y is greater than or equal to 0. All right, so that is how we'd set up this problem. We will continue looking at this problem in section 3.3, where we're going to solve it. If you have any questions, get in touch.